Partitioning is crucial. Create separate compartments for coolant and control equipment, with a physical barrier such as a wall or panel to prevent spray or leakage. Provide a catch pan below the coolant reservoir to collect any spills. Install a leak detector to alarm in the event of a leak. Keep coolant plumbing away from electrical controls and other critical components. Use baffles or shields to deflect fluid in case of a rupture. Consider installing automatic or manual shut-off valves on coolant supply lines to isolate the system in case of a leak. Rigid plumbing can be more susceptible to damage or vibration. Use flexible hoses to minimize potential leakage points. Educate operators on the importance of maintaining the coolant system and responding to leaks or ruptures. If possible, use a coolant reservoir with double walls to provide an extra layer of protection in case of a leak. Consider adding a second catch pan or containment system around the entire machine to capture any spilled fluid that may escape from the primary catch pan. Install multiple leak detectors in different locations within the compartment to increase the likelihood of detecting a leak early on. Instead of routing coolant piping away from sensitive devices, enclose it in a protective casing or conduit. Select plumbing connectors that minimize the risk of leakage or decoupling. Conduct regular maintenance and inspections of the coolant system to identify any potential issues or leaks early on. Refer to Annex K in NFPA 79 for additional guidance on safeguarding electrical equipment from liquids. If the situation is particularly complex, consider consulting a specialized engineering firm with expertise in electrical safety and fluid handling. The National Fire Protection Association 79, or NFPA 79, is the electrical standard for industrial machinery. Section 12.2, 2.1 addresses the separation of control equipment from coolant and oil reservoirs, mandating complete isolation within readily accessible and enclosed compartments. Section 12.2, 2.2 prohibits the placement of pipelines, tubing, or devices handling air, gases, or liquids within enclosures or compartments containing electrical control equipment, with exceptions for equipment cooling electronic devices and integral components of listed equipment separated by suitable barriers. When installing liquid-cooled motors or liquid-cooled curing light sources, several strategies can mitigate risks associated with coolant leaks. Firstly, partitioning the coolant reservoir, heat exchanger, and pump from other equipment is crucial to contain potential spray from bursts. Secondly, providing a catch pan capable of holding the entire fluid volume is essential. Thirdly, installing a leak detector can provide early warnings of coolant leaks. Fourthly, routing plumbing away from sensitive devices and providing baffles to deflect fluid from ruptures can protect critical components. Although ruptures may seem unlikely, proactive measures can prevent damage from burst or split hoses and pipes. Even within the same overall enclosure, partitioning can significantly enhance safety. Consider these additional protection measures. A double-walled coolant reservoir provides an extra layer of defense against leaks. A secondary containment system around the entire machine captures any spilled fluid that escapes the primary catch pan. Multiple leak detectors placed in different locations increase the chance of early leak detection. As an alternative to routing coolant piping away from sensitive devices, enclosing it in a protective casing or conduit offers another layer of protection. Selecting plumbing connectors that minimize the risk of leakage or decoupling is also important. Regular maintenance and inspections of the coolant system are essential for identifying potential issues early. Annex K in NFPA 79 provides additional guidance on safeguarding electrical equipment from liquids. For complex situations, consulting a specialized engineering firm with expertise in electrical safety and fluid handling is recommended. Implementing these strategies helps ensure compliance with NFPA 79 and minimizes risks associated with liquid-cooled machinery.